Okay, so we're starting trigonometry, and it's not nearly as complicated as it may sound, but it, just like the special right triangles, is all based on similar triangles. So if you think about it, every 30, 60, 90 triangle is similar to each other. That's why the ratios work and the rules work. Every 45, 45, 90 triangle is similar to each other, and so that's why those work. So the same thing kind of goes for trig. Well, not kind of goes, it does. We know we can use Pythagorean theorem to find the missing side of a right triangle if we know two sides. We can use special right triangles if they're special. And then the trig comes into play where we can use trig even if we could use special right triangles or Pythagorean theorem. But it allows us to find measurements when one of those other two ways doesn't work. Where Pythagorean theorem and special right triangles will give us exact answers sometimes, the trig will not. So those are still the best ways to handle those problems. But then trig allows us to use it, for instance, like if you look at these triangles as a 32-degree angle. We'd still be able to find stuff because that one's not special. All right, so the word trigonometry comes from the Greek words trigon, which means triangle, and metron, sometimes said metria, which means measure. So it literally just means triangle measure. And just like Pythagorean theorem, has to be right triangles. I want you to write at the very top right here, right triangles only. Right, and then in parentheses, for now. Okay, because you can use trig on triangles that are not right triangles, but we don't get into that in geometry. All we are doing is right triangle trigonometry, so as far as you're concerned, it's right triangles only. You don't use it at all in Algebra 2. When you get into pre-cal, you'll look at the right triangle trigonometry and then also apply it to triangles that are not right triangles. But if you try and apply it to triangles that are not right triangles right now, you're going to be making stuff up, so just don't even do it. Right? So as far as you're concerned right now, right triangles only. And we do this just like you do most similar triangle stuff with ratios. And the ratio in math, what does the word ratio usually mean for us? Fraction. Ratio should make you think of a fraction. It's a comparison of two things, but mathematically, fraction is where your brain should go. So it's a ratio of two sides of a right triangle. Okay? The ratio that we are going to use is what's called a trigonometric ratio. Trigonometric sounds real fancy. It's just a different form of the word trigonometry. Okay, so trigonometric ratio. It's a trig ratio. So I'll refer to them as trig ratios, also refer to them as trig functions sometimes. We don't really look at them graphically or talk about them from a function standpoint in geometry very much, but it is a function, so either one of those words is acceptable. This next little part here, I want to make sure that you understand how it relates to similar triangles, because I feel like we get into trig sometimes and you understand it and you can do it, but you don't really understand where these magical numbers come from. Well, there's really no magic to it. It's what it is similar triangles, which you've been doing for a very long time, because similarity is something that you've been doing since junior high for sure. So this little part here, we're going to do this. It's not anything that you're going to have to recreate or do again, but I just want to show you how it kind of all works together. So these three triangles here, are they all similar to each other? Yes, and how do we know that? Okay. By what? Angle, angle. They are similar by angle, angle, right? And that's something that you're going to have to continue to be able to identify, all the way through. That we've got similar triangles, they're similar, we know by angle, angle. So if I label these side lengths, I'm going to label this side P, this side R, this side Q. So if the other two triangles are similar to this one, then if I take so side P, or the side length that is P, is across from the 32-degree angle. So if I go across from the 32-degree angle on this one, and I put 2P, then what do I have to multiply the other two side lengths by? 2 in order for them to stay similar, right? Like it doesn't matter what the number is, it just has to be the same. It could be 6.382. It doesn't matter. We're going to use nicer numbers, but it has to be something. So if these are going to remain similar, then if this side got multiplied by 2, this has to become 2R, and this becomes 2Q. Make sense? Basic concept of similarity. Then here across from 32, I'm going to make this 3P. which means this has to be 3R and this has to be 3Q. Okay. So the concept of similarity, the types of problems that you have solved in the past with like a flagpole and a shadow, right? So your height corresponds to the flagpole's height, and then the length of your shadow corresponds to the shadow of the flagpole, right? You've read problems like that. So what the difference is, we're not comparing two triangles to each other. I don't look at this, I'm not setting up corresponding sides. Because when I do that, even when they are similar triangles, my ratios change. So here, if I put 2P over P and 2R over R and 2Q over Q, they all reduce to the same thing, which is 2, right? But when I put 2P over 3P and 2R over 3R, now I get 2/3. So you see how depending on which two triangles you choose, your ratio changes, right? So then help me when it's a bunch of different ratios. The difference is, and what a trig ratio is, how it differs from that, it is a ratio of two sides of a right triangle. We're not comparing two triangles to each other. It's a ratio of two sides from the same triangle. So that's what this little setup over here is. First of all, let's fill these in, because we already said that they're similar. So if I name the first one ABC, then this little one right here, what would I have to name it? DEF. And then the last one, XYZ. So they all happen to be alphabetical. We know that's a coincidence, right? All right, so instead of saying, you know, shadow to shadow and person to flagpole, that type of relationship, we're looking at these two sides actually come from the same triangle. So the length of BC, see how line segment BC is across from 32? And AC is what part of the triangle? Hypotenuse. And so EF is across from 32. This is the hypotenuse. YZ is across from 32. This is the hypotenuse. So I'm consistent in the pieces, right? Opposite over hypotenuse, and so forth. You with me on that? When I do that, let's actually fill those in. The length of BC is 3P over the hypotenuse, which is 3R. EF, which is P, over DF, which is R. YZ, which is 2P, over XZ, which is 2R. So I set up these little fractions. Can I reduce these? Yeah, the 3's cancel out. Nothing cancels out here. The 2's cancel out. So I end up with the same little ratio, whatever it is. And that ratio is the same. If I pick just a random right triangle out in the universe that has 132-degree angle in it, and I find the side length across from 32 and put it over the hypotenuse, it's going to reduce to this exact same fraction right here. That is what a trig ratio is. This is one of the 6 different ratios, just putting the opposite over the hypotenuse. So that's where it's coming from. It's an act similarity, some magic somebody made up, invented, right? Nobody invented this stuff. We just discovered the relationships. That, in a nutshell, is how the similar triangles kind of relate. Again, you're not going to have to recreate that. I know that doesn't always help everybody, but it does sometimes help some people kind of make connections to where in the heck this stuff is even coming from. Okay? So let's talk about what these ratios are. There are 6 trig ratios. We only talk about 3 of them in geometry, really. I'll probably at least mention the other 3 after a while. But once you learn 3 of them, the other 3 are just reciprocals of those, so you pretty much learn all 6 at the same time anyway. You just don't even realize it. We use them, remember, it has to be a right triangle. This is where all these ratios are based off of. Even when you apply it to triangles that are not right triangles, it's still based off the similarity of the right triangles. We have a triangle here. This doesn't have any specific like numbers or values, so it's very, very generic. The first thing you have to decide is, first of all, that you have a right triangle. We have a right triangle. That's really all we use that right angle for, making it a right triangle. Then you have to decide which one your important angle is. Yeah, C is pretty important because it makes it the right triangle, but that's never the angle that you use, okay? You use one of the 2 acute angles. And you decide which one is important based on the problem that you're on, which is going to be a super easy decision to make. Right now, since this is very generic, I'm just going to tell you which one we're going to use to get this started. We're going to use B just because I said so. The rest of them, it doesn't matter what I say, you go with what the problem does, okay? So we're going to use B. So I have a right triangle. B is my important angle. I know I'm going to use trig. So then I need to label my triangle. So just like with the 30, 60, 90 stuff, if you can label it correctly and set up your little equations, the rest is a piece of cake. Same thing here. Obviously the labels are different, but you still got to label it. You find what your angle is and you mark it. You draw an arrow across from it. This is the opposite side. What you will really write to label it is just OPP. I want you to write out the whole word on your notes like that, but you don't have to write out the word opposite every single time. What's my red segment? Hypotenuse. So this is a hypotenuse. Okay, we abbreviate that HYP. And then, so here's my angle. This is the side opposite it. And then this side right here is attached to it. I know that the hypotenuse is attached to it also, but the fact that it's the hypotenuse is more important. So as far as the leg goes, this is the one that is adjacent. And you abbreviate that ADJ. That does not mean adjective. Okay. So if you can label your triangles with opposite, hypotenuse, and adjacent, know what your ratios are, this is really not that bad. It's another one of those things that's going to look real fancy, but it's really not that big a deal at all. The 3 ratios that we're going to use, now make sure you continue this like I do. I'm leaving this space blank right here for now. I'm going to write down here and then we're coming back up here. Okay. So the 3 ratios that we're going to do for now, the first one is sine, second one is cosine, third one is tangent. Okay, sine, cosine, and tangent. That's probably the last time for a while that you'll actually write out the whole word because we use the abbreviations for most everything. Okay, that's how it's written. That's how the problems are written. One of my biggest pet peeves is you saying the abbreviations wrong because it really just makes you sound like a moron and you clearly have no idea what you're talking about. And past the first day, I have like 0 patience for it, and I'm not real nice about it. Just like here, when you abbreviate and you write this stuff, you are not going to say this is the op, the adj, and the hip, because this sounds like a moron, right? I mean, that's not what that is. An abbreviation is just that. This abbreviates the word opposite. So when you see this, you say opposite. Does that make sense? If your doctor's name is Dr. Smith, do you walk in and say, hey, Dr. Smith? No, you don't. Like, that doesn't make any sense. So you have to know what it means. Make sure you learn that very quickly. If you wouldn't say Dr. Smith here and op and hip here, you're not going to say these weird either, all right? So the abbreviation for sine. Okay, then. Sine is S-I-N. Cosine is C-O-S. Tangent is T-A-N. That is sine, cosine, and tangent. It is not sin, cos, and tan. Okay? That is not what that means at all. Okay? So to set up little equations, the sine, cosine, and tangent by themselves like that, that's just nothing. That's just like having a square root sign floating around somewhere. I have to take the sine of something. So sine, cosine, and tangent, you always take that of an angle. So we're using angle B. So the sine of B, cosine of B, tangent of B. And remember, these are trig ratios, so those are going to be equal to fractions that we set up. Okay? And the ratio is of the 2 sides of a triangle. And so how you put these in the little fraction there is what changes whether it's the sine, cosine, or the tangent. So the sine ratio is always the opposite side over the hypotenuse. And so the way that you say this, what comes out of your mouth here is the sine of B is opposite over hypotenuse. Okay? The sine of B is opposite over hypotenuse. It's not sin B equals op over hip. No, it means nothing. Okay? Then the cosine of B, that ratio is always the adjacent over the hypotenuse. And what comes after sine, immediately after sine, cosine, or tangent? That right there is always an angle. It may be a variable that represents an angle like it is right now, or it might be a value that is that angle, just depending on what kind of information you have. And then the tangent is always opposite over adjacent. And what's in the little fraction here, that is always side lengths. So you would never take the sine, cosine, or tangent of a side length. That doesn't make any sense. And you wouldn't have an angle measure in the fraction over here. So sine, cosine, or tangent of an angle is equal to the opposite over the hypotenuse, or adjacent over hypotenuse. It's side length over side length. Okay, everybody good so far? Okay, so there's a lot of new information right now, which in the end is not difficult at all. The why we care and why we're even doing this has to start coming tomorrow. So today you've just got to stay with me, learn the names and how to set them up, right? And how to find them, even though you won't even have a clue why you're finding what you're finding yet, okay? Because I can't, it's too much to kind of give you all at one day. So as long as we can do it and we can know what they are and how to set them up, we're going to get to that point, okay? Now, labeling should be a piece of cake. Setting it up is a piece of cake as long as you can remember which one's opposite in hypotenuse and which one's adjacent hypotenuse, that sort of thing. So we have an acronym for that. Y'all know what an acronym is? Okay, sometimes acronyms you can pronounce, sometimes you can't. Like PMHS is an acronym, but it doesn't really make a word. It's kind of like DER, like that's not an acronym, but you would sound the same way trying to pronounce that. STAR is an acronym. Ironically enough, the word is spelled wrong on a test where you need to know how to spell, but whatever. But we say STAR instead of the State of Texas Assessment of Academic Readiness, because that's a lot of words, right? If you spell an acronym wrong, it doesn't help you any, right? Because the letters there tell you what the words are. So the acronym I'm going to give you, if you write that at the top of your paper every time you do trig, you won't have a problem with this stuff at all. This is pretty much universal. There are other ways, but I would say like 95% of people, probably more, that have ever done trig have probably used this acronym. But spelling it correctly is the key. It's not crazy hard, but I have seen people spell it wrong. Then you're just going to do everything wrong. So that's what we're going to write. We're going to write the acronym right here in all caps. I'm going to tell you how you're going to use it. So it's SOHCAHTOA. So that's not a real word, but it's pronounced SOHCAHTOA. Okay, so you write SOHCAHTOA, spelled like that, at the top of everything. And the best thing for you to do is to write it down and then check yourself to see if you're right. Don't copy it down, because then you're actually doing it from memory. And if you do it every time, then it's way more likely that when it's really important, you'll spell it correctly. Okay? So here's what this means. This tells you that the sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Does that make sense? So that tells you right there, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So it's lined out for you every time. You don't necessarily have to write what's in orange every time. Clearly you need to do that here, but at least what's in blue, you write SOHCAHTOA at the top of your paper and you're good to go. Okay? And this won't be nearly as complicated as it may seem at the beginning. Okay? Everybody understand how to use that and how that relates to the little ratios we set up? Okay. We good? All right. So let's go to the inside here. So just like I said, at the top we are going to write, once my page turns, there we go. Write SOHCAHTOA. Now this says, write each trigonometric ratio as a fraction and as a decimal rounded to the nearest thousandth. We are not doing the decimal part today because today we're not touching the calculators. Tomorrow is when we'll start using the calculator. Not because it's nice to have, because we can't add and subtract, but because it's pretty much required for what we're doing. Okay, it's a tool that we use, not a crutch, right? If you have not gone into Schoology and downloaded the calculator that's in the materials folder onto your tablet, I highly, highly suggest that you do that, even if you have your own. You don't need a fancy graphing calculator. Scientific calculator is enough. I know most of your phones do it, but a lot of times it's easier if it's not your phone. Like you can use that, but it's still not as nice as like a separate calculator or something on your tablet. But if you go home and just ask if there's any calculators laying around, you may have one like shoved in the back of a junk drawer. Because again, they don't have to be fancy. The graphing part isn't important. It's just having the sine, cosine, and tangent buttons on there. But on your tablet's good, because even if you have your own calculator, you do not need to bring it with you. You don't want to risk losing it, breaking it, whatever, getting it stolen, because I have calculators that we're going to use in class. But if you're sitting in math time or before after school or whatever, and you're not in a math teacher's room, then you can use that exact calculator that we use in class on your tablet. So it's just nice to have. You don't have to have service, you don't have to have Wi-Fi or anything once you get it downloaded. But I would suggest that you do that today if you haven't already done that. That way, if you have any issues, I can help you with that and make sure that you get a working one. Okay, but we don't need them right now anyway. We're going to find sine, cosine, and tangent of A, and then sine, cosine, and tangent of B. So if I'm going to start right here, which angle do you think is my important angle? A. See how easy that is to decide? People say, how do I know which angle? Because using B would make no sense here, right? So sine of A. So A is my angle. So I'm going to label my triangle. There's my angle. Draw my arrow. That's the opposite side. That's the hypotenuse, because it's across from the right angle. This one is adjacent. Again, just like 30, 60, 90, you label those wrong, you're kind of out of luck for everything else. So you've got to make sure you get them set up right. We are looking for the sine. Our acronym tells us that sine is opposite over hypotenuse. So I'm not going to make you write the words every time, but we're going to do this on the first one. It's opposite over hypotenuse. So then I can just pull the values off of the triangle. Opposite is 24 over the hypotenuse, which is 26. And then I reduce it. What does that reduce to? 12 over 13. So that's the sine of A. I know you don't know why we found it, why we care what we do with it yet, but we just got to be able to find it right now. I promise you I'll get to the whys. Everybody okay so far? You can do it even if you don't know why you're doing it. Okay. What do you think the units are on this? Feet? Okay. So let's see what happens. Now cosine. I know from my acronym that's adjacent over hypotenuse. I won't make you write the words this time. But we are going to substitute in the units as well. So cosine is adjacent over hypotenuse. Adjacent is 10 feet over 26 feet. What happens with the feet? They cancel out. So this thing doesn't have any units on it at all. Okay, there are no units on a sine, cosine, or tangent value. It's just a ratio. It's a multiplier. Kind of like when you solve for x. X rarely has variables on it. It rarely has units on it. When you substitute it back in, you might have units for whatever you're doing, but the value itself doesn't. All right, and then this reduces to 5 over 13. All right, tangent, we know, is opposite over adjacent. So that is 24 over 10, and that is 12 over 5. All right, so do you feel like that is something you could set up and find? Yes. Okay, we're good then. So now we move on to D. We want the sine of B. Well, I'm changing angles. So since I'm changing angles, I have to label my triangle according to that angle. This is my important angle. This is now the opposite side. It's no longer adjacent. It's now the opposite side. Hypotenuse is still the hypotenuse because that doesn't change. And then the side that was opposite is now the adjacent. Everybody okay with that? So those things change when you use the different angles. Sine is opposite over hypotenuse, so that is 10 over 26. And that reduces to 5 over 13. Cosine is adjacent over hypotenuse, so that is 24 over 26. And that is 12 over 13. Then the tangent of B, opposite over adjacent, so that is 10 over 24, which is 5 over 12. Okay, everybody good so far? All right, so now look at the sine of A and the cosine of B. What do you notice? They're the same. Does it make sense that they're the same? Well, it's all from the same triangle, so it can't be similar to itself, but yeah. Okay. Sine and cosine both have hypotenuse as the denominator, right? The only difference is what the numerator is. One of them is opposite, one of them is adjacent. When you change the angle, what changes is which one's opposite and which one's adjacent. Does that make sense? So every single time in every triangle, the sine of one angle will be the cosine of the other one, and vice versa. And then look at the tangents. 12 over 5 and 5 over 12. Those are just what? Reciprocals. Okay, so they're reciprocals because you've just switched what the opposite and the adjacent are. Does that make sense? Okay. We all get at this point? We can find them. I know you don't know what they are. That's okay. Now, we're going to skip this little section right here because it requires a calculator. We're going to start with that tomorrow. We're going to do this right here. This is what we need to finish with today. So trig ratios and special right triangles. We need to find the cosine of 60 and the sine of 60. And we don't even have anything on our triangle. Now, when you get to pre-cal, you have to just know what the cosine of 60 and the sine of 60 are, and the tangent of 30 and all that kind of stuff, of all your special angles. That is not something you need to memorize in geometry because you don't use this at all in Algebra 2, so chances of you actually remembering it all when you get to pre-cal, slim to none. But you do need to be able to find them. It's okay if you can't rattle them off to me right now, but you got to be able to find them. Is this a special right triangle? Yes. So we're going to label it like that. Across from 30 is S. This is 2S. This is S squared of 3. Now what I need is trig values, cosine of 60 and sine of 60. So I also need to label my triangle with the trig stuff. In this case, 60 is my important angle. So across from 60 is my opposite. This is the hypotenuse, and this is the adjacent. Okay, so I have it labeled as a special right triangle because it is, and then I have it labeled for trig because I'm looking for some trig values. All right. So we're going to start with cosine of 60. Cosine, according to my acronym, is always what over what? Opposite over hypotenuse, right? So, oh, it's adjacent, duh. I heard opposite over tangent or something that threw me off. It's okay. This was like, what? All right, cosine is what over what now? Adjacent over hypotenuse. It's this, I know, that's what I said. It is adjacent over hypotenuse. Sorry, that whole tangent thing blew my mind. So cosine of 60 is going to be S adjacent over the hypotenuse, which is 2S. Can I reduce that? What happens with the S's? They cancel out. So am I just left with 2? It's 1 over 2. Good. So the cosine of 60 is 1/2, right? Something that eventually you'll just have to know. Your calculator will give you the 0.5, so you can figure out that it's 1/2. But let's look at sine of 60. Sine of 60. Now, sine is always what over what? Opposite over hypotenuse, which is S squared of 3 over 2S. Can I cancel anything out here? The S. So that leaves me with square root of 3 over 2. That is not something your calculator is going to give you, right? It's going to give you some nasty decimal when that is the exact form that you would actually need. Okay, so again, you don't have to be able to just memorize these. No sense in that for y'all right now, but it is something that you need to be able to find with exact values, understanding your special right triangles. Okay, we all good so far? So right now, you need to know what trig means, know the 3 ratios we've talked about, sine, cosine, and tangent, SOHCAHTOA so that you can set them up, be able to set them up like we did at the top of this paper right here to get your fractions, and to be able to get them from special right triangles. Okay, we're going to continue on and finish some stuff up tomorrow, make it all make a little bit more sense. But can you at least get through that right now? Do we have any questions about that much right now? Okay, awesome. I wouldn't suggest necessarily gluing this in yet because we're not done writing on it. It's probably easier to write on if it's not glued in. I don't care if you do. I'm just kind of giving you the heads up there.